So, two secondary alcohols, two different conditions. So, secondary alcohols, um, and these are alcohols are a little different than alkyl halides because alcohols themselves are not very good leaving groups. So you need to activate them in different ways. Simplest ways with like something like HBr, and that's going to turn this into water, which is a really good leaving group. The problem is going to be is that you're going to create a carbocation. Um, Not a problem, but you just got to recognize once I do that first step, I make this, I'm going to make a carbocation, which is fine, but then the issue with carbocations, right, so it's more like an SN1. The issue with carbocations is, of course, that they will rearrange. So if you look at this as a secondary carbocation, I have methyl groups over here on carbon 2 that will shift, and that would give me a new carbocation here on carbon 2, 1, 2, 1, 2, because of methyl shift over. There's a tertiary carbocation that's more stable, and then of course all along the way Br minus has been here, then Br minus would add, and you'd get the bromine now on carbon 2 instead of carbon 1. So things like HBr, HCl, HI, H2SO4 and water, those kind of things, when you activate those with alcohols, they'll make a carbocation. Luckily, chemists realized this and said, well, wait a second, we don't always want to have that happen. And they have reagents like SOCl2, where you will do a SN2 reaction. You're going to activate this. I'm not going to go through the mechanism for this activation. We've done that before. You can check it out. Eventually, you're going to make SO2 gas, Cl minus, and pyridine. And pyridine is going to be involved as a base. But you're going to essentially get here no carbocation rearrangements. And you're going to get the alcohol displaced in an SN2 fashion with the chlorine. So it's a way to turn an alcohol into a good leaving group without forming carbocations. And we talked about a couple other ways. Tosyl chloride was another way. Yeah, and we've actually used SOCl2 to actually turn carboxylic acids into acid chlorides as well. So we've seen that a couple times, how to turn a carboxylic acid, essentially something like this. It's the same mechanism actually, same idea. Turn this into this. Right, SOCl2 will do that too. So it's again converting alcohol into a Cl. Is a way to do that. No carbocation. So.